So today we'll be covering the midpoint and length of a line segment. So this chapter's been split up into two parts. So you have the midpoint. No, actually, I'll just get a thicker one. There we go. Midpoint and length. Okay. So we're going to be covering the midpoint in the first half, and then in the second half we'll cover the length of it. Okay. So hopefully by the end of this chapter 4H here, this is pretty much the goal. So everything that I've pretty much just talked about just earlier, okay? And your success criteria is that you can find the midpoint of a line segment between 2 points and you can find the length of a line segment using Pythag. So just going back to our Pythagoras roots, okay? So you got to be careful with this kind of stuff. But first off, let's just talk about what a line segment is. So a line segment is pretty much a straight line that has two fixed endpoints. Okay. So it starts at one coordinate and ends at another coordinate. And like what you're supposed to be picturing is like if you draw a straight line from point A to point B, halving that it takes is the line segment. So if you have a look at my diagram up here, I have two coordinates already laid out. So I've got one starting right here. So that's 1, 0. And then I have another one up here, which is actually 4 and 4. So those are my two coordinate points, and I've just drawn a straight line through those points right there. Okay. And it doesn't extend, it just stops at those points. Okay. Now, let's talk about the midpoint. Midpoint is a capital M. It's not lowercase m because lowercase m is the gradient. So you have to use capital M to represent the midpoint. Okay. What is the midpoint actually? It's pretty much the halfway point between the line segment. What you are actually doing is finding the average position of the two x values and y values. Okay, just let me plug in my charger real quick. Ah, oh, where is my thingy? Okay, is that the charger? No, that's the wrong one. Which one is it? Ah, here we go. There we go. So what you're doing when you're averaging the x values is you're finding the middle point horizontally, because remember your x and your y axis, it makes sense. So x is the horizontal, y is the vertical, and for the y values you're finding the middle vertically. Now there's a formula that we use to determine that. This is the formula right here. M equals to this. So this is written as a coordinate point already because it's inside the brackets. So what you're doing is you're finding x1 plus x2 and you're halving it, so your average of x, and then y1 plus y2 divided by 2, that's the average of y, okay? Now, I'll just use some time to copy it down. There we go. Okay, let's just do an example right now. So I've got two coordinate points here. I have 1, 0, and I have 4 and 4. So it's just pretty much the same as my diagram from earlier. So we're just using the same example because I couldn't be bothered making one up. So here we go. So I'm just going to write out the formula first. x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2, just like that. And if you wanted to define which one's x1, y1, x2, y2, you can do that. Okay, so I'll just do that right now for you just to visually see. I can't be bothered choosing which one is which. So I just go in order, okay? So if I substitute these values in, my x1 value is +1. So I'm just going to replace it there. Plus, what's x2? So x2 is where 4 is. So I'm going to write that. And do that divided by 2. I'm going to put a comma. Y1 is, let's have a look here, it's 0 plus, what's y2? Y2 is 4, so 0 plus 4, divide that by 2. And I'm going to put it around in brackets, okay? Now you just simplify it. What's 1 plus 4 divided by 2? So just go at it slowly. 1 plus 4 is 5. And then since you can't really do it divided by 2, you just leave it there. And then 0 plus 4 is 4 divided by 2, just like that. And this ends up just being 5 over 2 over 2. Now, if you're wondering what 5 over 2 is, 5 over 2 is pretty much the same thing as 2.5, aka 2.5, okay? So that means the midpoint between 1, 0 and 4, 4 is 2.5 to 2. And it will make sense once I show you in the next slide, like their graphs, and then we can sort of just like point it on, okay? But let's just go through like the example first, okay? So m equals to x1 plus x2 over 2, and then y1 plus y2 over 2, just like that. Now, don't worry if your brackets are like not same level. Okay, ideally you want it the same, but like, if one's a bit off, it's perfectly fine. We understand what you're doing. As long as you have this formula out, all you have to worry about is substituting and simplifying it down, okay? So that equals to, let's just label which one's x1, y1 again. x1, y1, x2, y2. So -3, -2 is x1, y1. 5 and 3 is x2, y2. Now, you got to be careful when there are negatives in the picture because that changes the whole dynamic, okay? So let's just be careful. So x1 is -3 plus 5 over 2 like that. Y1 is -2 plus 3 over 2 just like that. Now let's just worry about simplifying it first. So in the numerator, what's -3 plus 5? That is actually +2 over 2. And then -2 plus 3 is +1. And that gets divided by 2. And then just clean it up further. 2 over 2 is just 1. And then 1 over 2 is just 1/2 anyway. Okay. And if you don't know what 1/2 is, this just technically means 0.5. Okay. So I'll just circle it. So I'll circle it just like that. So our midpoint between -3, -2, and 5, 3 is actually 1.5. Now let's just have a look here. So I've just got the graphs out already done for you. Let's just plot where the midpoint is. So let's just go to part A, 1, 0, 4, and 4. So that's what? 2.5 to 2. So let's just find where 2.5 is. Let's have a look. So if I know that this point is 3, that means over here is 2.5, and my y value is 2. And if you have a look right there, that generally looks like the halfway mark between the coordinates, yeah? So that's basically what you're doing. So if you wanted like a clearer picture, you're pretty much just drawing a triangle and you're just finding the halfway point. That's it. Generally looks halfway. Now, -3, -2, and 5 and 3. Let's have a look. What's our midpoint again? It was 1.5. So let's just find where 1 is. So let's just check our scaling real quick. That's 1 right there. That's 3. That's 5. on my y-axis, I can see that this is +1, and halfway is just somewhere there. So your midpoint is actually right here where I have just circled. And just looking at the graph itself, it generally looks like the halfway mark. So that means 1 and 1/2 is indeed the midpoint. So this one is what was this again? 2.5. So 5 2, just like that. Okay. We're now on to the second half of the chapter. So this is the length of a line segment. Okay. So you're basically finding how long is this line specifically. So that's why we say distance wise. It's pretty easy. You're going to be applying PyFag. Okay. So if you have a look, is this the same example? Yes, it is indeed the same example. Okay. So you're just creating a right angle triangle. Now, what you're going to do is find the difference in the x values. This will be your horizontal length and the difference in the y values, which is going to be your vertical length. Very similar to your rise over run situation. Okay. Now, if you remember from PyFag, PyFag just states that if you have a right angle triangle, you can just label as such. Basically, if you square the longest side, it should be the equivalent of you adding up the squares of the smaller sides, okay? So that's what we're going to do. So the line segment is the hypotenuse. Yep, that makes sense. As you can see, it's in my diagram right there. Now, because the formula for PyFag is c squared equals a squared plus b squared, we're now going to change what they represent now. So I'll just highlight in a different color. I'll use blue. So the A just means the change in X. And then in green, the B just means the change in Y. And then obviously the change in X is actually so the change in X is in blue. And then the change in Y is this, Y2 minus Y1. And the actual official formula is this. Length equals whatever this is. Okay. So length equals square root x2 minus x1 squared plus y2 minus y1 squared. Okay. So this is the actual formula that you are using right here. This is all you need. So this is an example that I've already done preemptively, but let's just go through it. So in my example, I've got the two coordinate points of -1 5 and -3 2. Now I've officially labeled which one's x1 and x2. So what I've done here is I've substituted the values in. So x2 being -3, so -3 minus, and this is something you have to be careful about, this negative situation. So I subtract it by -1. And then I have to square the whole thing. You got to be very careful with your algebra here. And for my y2 minus y1, I have 2 minus 5. Now, if you clean this up, the double negative situation, it turns into a plus sign. So it now becomes negative 3 plus 1 squared plus whatever's here, 2 minus 5 squared, just like that. So when you start simplifying it, negative 3 plus 1 is negative 2. And I have 2 minus 5, which is negative 3. If you square both of them, so I'll just write on the side here, negative 2 squared is just negative 2 times negative 2, which is positive 4. And then negative 3 squared is a similar, negative 3 times negative 3, which equals to positive 9. And then you end up with 4 plus 9, square root 13. Now, because they don't give us any units whatsoever, you must make sure you put in the word units. Okay? Because you're talking about distance now, so you're trying to know how long it is. Okay? So make sure you put in the word units in your final answer. These are the questions you got to do. Please make sure you do it. If you have any questions, please let me know in class. Okay? Take care.